one last session before the lunch. So I'm assuming everybody is doing well. Got a lot of great talk about talking about design, so for platform engineering and stuff, right? Now, all of that is something you need to do, and you need to kind of get to the level where you can actually build the application, right? We also got a lot of developers here and a lot of engineers. So I'm a senior SRE at home, right? So I essentially work on the day-to side of things. While I'm involved in the design phase, but of course, like security, sir, I'm not a proper architect. So I'm going to come here, talk about code, leave, and maybe by one hand. Okay? So yeah, I'm going to talk about operating random tasks, right? So everybody what Kubernetes operators are, people know what Kubernetes is, I'm sure now, right? Basically, I'm going to be talking about this. So I'm going to give a brief introduction what Kubernetes operators are. I'm assuming most people know, so I'm just gonna, just give a brief summary about it. Then I'm going to talk about some of the general best practices. What are some of the things that you should do in general when writing something, when these are ready. So there's no specific best practices that I have seen maintaining some Kubernetes controller introduction. And then I'm going to talk about observability, right? Like everybody, they all know, like, hey, what is the code? And how do I see what is happening, right? What do I know about it? What is happening at this exact time? That's very, very important when learning anything in cloud. So this is basically what the agenda is. I'm going to be giving, code snippets as to how exactly to do that, right? So again, I'm not really talking about what you need to build the operator or what else is this. I'm assuming you already have and I'm not. So I'm clear that how you build and how do you make sure that operator performs, right? The operator does what it needs to do, doesn't crash, doesn't take down a function, right? Yeah. Let me break up. What are Kubernetes operators? And how are we going to develop it here? Kubernetes operators are things where are essentially used to automate complex application management. Right? So you have a use case where you need to deploy a bunch of things together to a bunch of different places. We just saw audit example, right? We need to talk to a lot of different places. There's a lot of massive things that you need to do, right? You have to do all of these random things, but these random things have certain pattern to it, right? They have certain things to it. We can automate them, right? But one way to automate that is by using Kubernetes operators, right? Kubernetes operators allow you to define a desired state. So let's take an example of Prometheus, right? Where you are saying, okay, I need to deploy, run, operate, manage my Prometheus that are running in all of my clubs, right? I need to point the application. So how do you deploy them? You can either deploy directly a stateful set or a deployment, perhaps goes by a service, and them all in a health chart. Okay. What happens when Prometheus goes down? Right? Let's say somehow the number of replica count in the stateful set becomes zero. What happens then? Right? How do you ensure that always there? When you have to upgrade it, can you just essentially do upgrade the image stack version? No, you can't, right? You want to do some sort of blue green based approach. So all of these annual things what Kubernetes operators allow you, right? Basically, it encodes what humans know and have learned throughout the years, right? So that's Kubernetes operators. Some examples like Prometheus operators, ISP operators, plus there's a bunch of operators. I think most of the things that we love, tooling that we love have an operator associated, right? To ensure that they are working fine, right? And I think operators set up controller managers, which is essentially an operator, right? So you have a state and then goes there to create one. That is what Kubernetes operators are. I'll first talk about what are some of the general best practices that we can follow, and then some specific best practices. So general best practices. Any developer, anyone who uses Go here, how many people use Go or no Go reported? These are one of the people. So, Kubernetes operators are generally, and when I say generally, I mean 99% of them are written in Go. The reason for that is because Kubernetes is written in Go. So the communication is very, very well established in Go, right? Because of very, very robust client go library and a lot of that. So some general best practices are just follow consistent directory flow, right? So you have your main executable files in CMD, package for usable libraries, and nothing further for business logic. The reason I'm highlighting this is so that when you're navigating through your code base, because control operators are in general complex code, so if you structure it decently and repeatable in a repeatable manner, it's easy for you to navigate through code, right? And when you are doing troubleshooting, you don't want to just skip off and jump and figure out where something is, where you need to do. Uh, then always enable keep off endpoint. That is very, very, very important. Anyone who uses Go, any project that you use, always enable keep off, which is essentially a profiling tool, right? Which you can essentially hit, and then you get the keep down, you get the CPU performance level data, right? So in every single project on this, and it's very, very easy, right? You just have to import and export an endpoint where the peak off is going to run. And that's it, right? So it's very, very easy. So write comprehensive test. Okay. Everybody look at me. Write test. Please. Okay. If you take one thing from this presentation, write test. All the time, every test, right? Unit test, integration test, first test, all of those. That is very, very important. I have seen many incidents happening because of that. Please write test, right? If you're saying that, hey, it's a business logic, I know, no, you don't. Trust me. Tests are very, very important, right? And right, good unit test, if you're making API calls, right, you can use more things and stuff, right, to mock those API calls. So you can do input and output validation in your unit test for your function test. It's very, very important that you write really, really well written test, right? Yeah, the line good and technical comment. Again, this is just a very, very simple, just general hygiene. Best practice, right? Write comments, right? So any function that you define, just write a comment what that function does. That's it, right? So it's a very, like I think the panel, right, where what says that comment describe what a function does, code describes how it does. Right? You don't have in your comments, you don't have to decide how it happens, but what it does. So that when you are generating documentation, something like Go it automatically comes ahead and so that when those factors are important in other libraries, intelligence can tell you what that function does, what that method does, all of those things. So you can use all of these only if you're using good comments. And then error handling. That's also very, very important. In Go, errors are a first class type, right? So like strings. Errors are exported. So, this is like error messages well, right? So don't just do return error, right? If that's an error. Return open zero error and put some context as to what the error is about. So when you're debugging, you can know, okay, this is the problem, these are the issues. This is convenient now, but trust me, when you're writing into the which are in general, eventually consistent system, that becomes really important because when you're saying, okay, something says, well, why did it not work? Get a stack place, you need to understand where the error happened, right? So in complex logic with multiple packages, it's really difficult to get lost. That's very important. Use something like multi-error.group, right? That if you spin up multiple routines, you can aggregate all the errors together into one big error and then start connecting up to the main executable. Yeah, so I have realized a lot of people haven't known Go, probably doesn't feel, but I think these general best practices should be fairly common across programming languages, right? Yeah, some of the video messages may change, but I think writing good errors, just writing comments, writing tests, those are common things that every developer, every DevOps, everyone who's writing code should follow. Then yeah, let's talk about sort of controller and operator specific aspects. Now that we have maintained good hygiene for our code base, we have a good hygiene for code bases. Now let's talk about some of the best practices to ensure the operators that we are writing perform well, are successful, are doing what they need to be doing, right? Now let's work this in. Operators by default are not horizontally scalable. mind blown, right? All the DevOps engineers like, what? How can I save the even the software is supposed to be cloud native? Yes, the reason they're not was on is because they have actually really said what putting a watch on the API, on the API server and getting all the CR, right? So whenever we create a deployment those are Kubernetes. So what are all the deployment objects? It's very hard to shard it. It's important, but it's not very common in market. Right? Most operators will not be horizontally scalable. But you can vertically scale, right? Can actually make things concurrent, which what that means that you can have multiple objects be reconciling in the same or concurrently, or the same time but concurrently. So let's say you have objects that you apply, five CRTs that you apply to the you can have 10 teams reconcile concurrently. And this is a very important thing, right? When you are going to set up this manager, when you're actually enrolling your reconcile with the controller manager, you have to put this options, controller dot options, and configure concern, right? So this is a configurable field that you can configure based on your scaling needs, based on whatever your use cases. But most people miss this because by default this is set to one. So what happens is that if you have a cluster with a lot of chunks of these objects that you're trying to reconcile happening, you see, hey, why is it not performing? Why are we not seeing it picking up quickly? That's because at one time only one object is being reconciled. So one worker equals to one object. Right? So if you have five also that five objects can be reconciled concurrently. Again, I'm using the word concurrently because it's true, right? And it's not happening parallelly, it's happening almost almost parallelly, but it's not exactly the same thing. So yeah, vertical thinking is important. Then second is use aging. So while developing, I said that controllers and operators by design are not horizontal scale. You can still have high availability like you have a database, right? For example. Not the same thing, but yeah, we still have aging. What that means is that you can have either pod, which is actually doing the reconciliation, one standby pod, right? Which is basically just waiting. So you're taking your deployment object, you put everything else down just for the operation. And one of them will be using the application, which the other one will be standing one. Right? And when you see the apparently the CPU difference between these pods, because one is the standing one. And how it happens is that in Kubernetes, there's a concept of leader effect. But that means that there's one object called a piece where both of the pods try and set piece, right? Basically acquire them, but only one wins. And whoever wins gets the privilege of actually doing the reconciliation. And the other one is like, okay, I don't have the lead. I try again sometime. If I get a lead, then let's start. Right? What happens? The leader pod goes down. It fails to renew its pace, so the other pod takes it and starts moving. Right? So it will minimize the downtime, potential downtime that will happen. And if you follow that with DevOps practices of having these two pods in separate nodes, it reduces the attack downtime significantly, right? And by default, I think the lead collection time is like 15 seconds. So every 15 seconds tries to get if the leader pod is available. If it's not available, then start picking. It's very important to edge it, right? Especially when you're doing production deployment. And it's very simple. Right? All you have to do is just add this and hidden potency controller. That is very important, right? All of us, every operator that you see, every well-written operator that you see has to be available. What that means is that every single reconcile will not modify anything if the desired state does not. Regardless of how many times you delete, create, update, it's smart enough to do it. And how does it do it? So it gets every single object, and only if it needs changing can it will make things. So let's take an example of AWS LV controller, right? So everybody who's using AWS probably use AWS LV controller for AWS management. So what AWS LV controller basically does is it will list the list of load balances that it has created And the load balancer that is associated for the specific ingress or service object is very valid whether that ingress object has or whatever the configuration that has, whether it doesn't have the load balancer. If it matches, then it's like, okay, fine. If it does not, then it will be modified, right? So that means that it will be very, very properly implemented. But to ensure that we are not kind of modifying things which are not supposed to be modified. Right. A lot of people do this, which is on Kubernetes objects have a status and we will define all the conditions, what has happened, what are the events and all that stuff. What a lot of people try to do is to maintain this enough time, people try to use it as a data store where let's say if they made a load balancer, store the load balancer ARN into the status field and then the next level is check the ARN and be like, okay, if I'm going to get this ARN and figure out. Don't do that. That's an anti-pattern controller. It's very, very difficult to figure out, but controllers do not have any state, right? Should not have any state. Let's call it that. What that means is that our controllers should be dumb enough to always figure out what is the real world scenario, what is the state of the real world, and take action based on that, right? They should be able to discover that. You don't need to store data anywhere. So, that is just keep in mind when you're writing controllers, that is definitely an antivirus. And when you're deleting things, right? When you're deleting, when someone has said, okay, I want to delete, they always remove finalizer at the end of the entire configuration. So finalizer is something that is applied to ensure that the CRT deletion is blocked until all the resources that was created were deleted, right? So let's take an example of AWS controller, right? If you delete the ingress object, it will first delete the load balancer. If for some reason it fails, it will block the deletion of the ingress until and unless that load balancer happens, right? We have to ensure that a lot of people don't do that. That the finalizer is only removed at the end so that we don't leave any awful resources, right? Because that is constant. And building on this concept of hidden potent controllers, we should always practice periodic reconciliation of actions. Right? So now this is going to be a bit of controversial thing, and people who have built controllers may not agree with this, but it's my opinion that our operators should do periodic reconciliation. So what that means is that when something is created, right, during the creation, you make the resources, you make the API calls to kind of create all the resources. And it's now created. It's in the status of ready and fine. But if nothing changes, right, there's no update happening. Your controller is sitting idle, it's not doing anything for that particular reason. But ideally it should, right? If you think about it, it actually should, because your job is to ensure that the desired state, which is in the AWS load balancer, again I'm taking the example of AWS controller. The desired state of the AWS controller is mapping itself. What if some engineer or some other process goes ahead and modifies that particular and by mistake deletes that? Your controllers won't get to know about it because it only does reconciliations when there is a creation, updation, and deletion. Right? Now, if there is no creation, updation, or deletion that happened on the state that is in Kubernetes, it will never go on. Right? That's why I am a big proponent of periodic reconciliation, which is that you should always have a period where it automatically does the entire reconciliation. And because the controller is supposed to be hidden, nothing will happen. Right? But if something changes, only then it will pick it up and set it back to how it was. That will ensure that we don't have a lot of infrastructure that is right? That's a big problem in Terraform and all of those people you probably understand. That to reduce the reflection, you have to ensure that it will be periodic. And what has happened means, because you're now doing periodic reconciliations, with scale, this may become a bit of a thing, right? So what happens basically means is you have a large configuration, for example. Like again, take a big ingress file that you have created probably, like a team. If you create a big ingress file with a lot of routes, you'll have a spreadsheet. Now, if you want to do desired state management, make sure each of these fields that are set here is also the case in the controller, right, or in the real world. So instead of doing that, what you can do is actually calculate the hash of the section, right? It's the entire thing that is there, calculate the hash. Canvas map, and you store that as an application on the CRS, right? And in the next user is going periodic then you again compute the hat of this segment and you map with the previously applied one. When you go through matches, that means nothing has changed in the basket, and you can actually go ahead without doing the expensive API call, right? And how do you calculate the hash? Very, very simple hash. Library there and right, hash structure. You can just create a hash and just copy the interface type. You can just provide the text of the object that you're doing because the interface type is essentially going to take any type that doesn't make a difference. And then it will return to you, basically a string with the hash value, right? And because now you have to have an input from an application here, and then you complete hash value. It was very small function. They were done for the data. The forward that is fine. Using runables to run some code in a loop, right? Now, controllers by design are equal, right? Like I said, when a CR is created, updated, what if you have something that does not always run? Yeah, you can create another service for it which does that. But for example, what if your service or your controller had to talk to Kafka, right? Or actually do some clear job which is closely tied to the life cycle of the controller, right? It's actually much complicated with things. Where it actually needs to do some things in a loop which is not part of the common reconciliation, right? So how do you do that? Controller manager provides space or runnable it when you have a start object. And what you do, you can just implement this interface and implement the start object, and it will run in a loop, and you can provide that to controller manager. And whenever the controller manager starts, directly start all the start this option with, and because of all the start option, you can put it in an instrument loop and have a ticker so that every 5 minutes can do some delivery. Right? For example, we read from Kafka. In our case, we also read from Kafka quite significantly. So what we have done, we have created variable. What that variable will do is will read messages from Kafka, do what it needs to do, and then restart. Right? So basically create a Kafka consumer within the controller code rather than have to create a own code, right? Or its own repository. So use runables because it's a very, very powerful way to run arbitrary code, and it basically allows you to run something like a cron job without having to create a cron job. Use print columns and shortening. That is very, very important, especially when you're doing production. Right? What that means is that when you're defining a stuff for the type for your RT, when you do kubectl get index, right? When you do kubectl get Prometheus rule, for example, you get a bunch of things, right? So you get the name of it, you get the age of it, you get load balancer URL, you get the account type, you get a bunch of things. How will this happen? That happens because of this. Right? When you first need to build a tab, print columns, for example. So you will essentially print those things when you do kubectl get that object type. Right? And short names is essentially instead of writing kubectl get my object type, just do kubectl get anything, right? Or my MO, anything short name, right? That kind of saves time in troubleshooting. Like that half a second save when there's an incident and you have to do this over and over and over again, that piles up. Right? That really piles up. You have to do these short different columns that okay, these are things that I want. So instead of doing kubectl get this for output YAML, you just do kubectl get this, you get that directly in the command line, you can file that to another utility and quickly start troubleshooting, quickly start debugging. And that's kind of is a very, very important thing as start, running through. Now, so that's my last point. How do you do automate, right? So, two very, very things, logging and monitoring. I will talk about those two, not tracing for now. So, but before controller manager comes with this, its own set of logger, you can create your own logger, provide that logger to it, and it will follow. It will use that particular logger to kind of log everything. I use that. Right? It's a very nice logger. It provides you with context and file names in the log. It provides you JSON schema and everything. Right? So that these log types to it and log everything. Right? A lot of developers don't do that. They basically do this. They know two types of logs: equal log and debug log. Sorry, equal logs and error log. Right? So there are a lot of different types of logging. Take advantage of that, right? When you're because if you're using data log or you're using URL, the cost of logs matter. Then if you cannot log everything in a normal day, but when there's a problem, you need to enable something like a debug log. You have to have, right? You have to have those things you're forced to be able to kind of trace those everything, trace through everything. So log a lot, put a lot of log, right? In terms of monitoring, every controller manager comes by default with a set of metrics, and this poses it on a metric endpoint. So we can learn when it poses on a metric endpoint, then provisions can split. But what if you want to know metrics, right? Like, let's say my controller makes calls to AWS. I want to know what is the time to what is the average time for AWS API calls, how many succeeded, how many failed, if they failed with what API code, right? So how do you add them? So controller manager provides you a global provision registry, and you can basically define your metrics like this, right? Prometheus, using a Prometheus library. You can use hotel as well. Sorry, hotel purist. You can use hotel as well. I Prometheus because of just a little bit of personally feel more performant. Right? Especially if you actually use Prometheus as well, but you can definitely use hotel. Right. So you can define the metrics like this, right? New counter, new gauge, new histogram, and stuff, right? And basically just when you init that metrics package, right, whatever package, you add that to the global registry. And those metrics will then be served on the same metric, right? But that will be just in space, you can put it in the one and then use the MCP server to kind of get data directly, right? So, yeah, that is about it, right, from best practice. And when I just talk from a core perspective, I didn't talk about design and stuff, right? That is something that I don't feel like I'm qualified enough. But yeah, that's it for how you should at least think about when you're writing it. Especially when they're supposed to have a question, it's not just a few. Lastly, we have a strong user group in Hyderabad. We have about 2,000 members, and we are also organized with all sessions all the time. Jayanth and Tanmay are the leaders of the community. So do reach out to them if you have any doubts. We are on LinkedIn, we are on Twitter. So look at the keep in touch for new meetings that. That's it. Thank you, everyone. I will not sure just time for questions. So maybe we'll take them. So, thank you.